Earth's seasons. In this video, scientists will be able to comprehend the reason for Earth's seasons by taking notes on how Earth's tilt affects daylight hours and the angle of sunlight. A lot of this video is going to focus on sunlight, so there's some important reminders. The first is that all heat on Earth comes from sunlight. Depending on where you are on Earth, you get different types of sunlight. Sunlight that is coming from directly overhead is direct sunlight. The heat in that sunlight is very concentrated. So direct sunlight provides more heat to an area. Indirect sunlight, on the other hand, is spread out over an area. And so you have less heat provided by indirect sunlight. Again, direct sunlight will feel warmer, indirect sunlight will feel cooler. To understand seasons, we also need a new vocabulary word. We're going to be talking about hemispheres. Hemisphere just means half of a sphere. And we can cut Earth into two hemispheres. You'll remember that the equator is the imaginary line that runs around the middle of Earth. So the northern hemisphere would be the half of Earth that is north of the equator, and the southern hemisphere is the half of Earth below the equator, or to the south of the equator. So in the objective, we saw that Earth has seasons because of tilt. So what would Earth be like without tilt? Well, first off, every day would be identical. We would always get 12 hours of daylight and 12 hours of nighttime. Regardless of the month, every day and night would always be 12 hours long. In addition, we wouldn't have seasons. Your temperature would really depend on your latitude. However, Earth does have a tilt. In fact, Earth is not straight up and down, it is tilted at a 23.5 degree angle. What that means is that as Earth revolves around the sun, as Earth goes around the sun, each hemisphere is pointed towards the sun for part of the year and away from the sun for part of the year. It's that tilt that creates the pattern of seasons. In this simulation, we're seeing the Earth rotate as it revolves around the sun. It is spinning as it goes around the sun. When we change the angle, you can see the axis of the Earth. Notice that the tilt of the axis does not change. At points, the top of the axis is pointed towards the sun, and at other points the axis is pointed away from the sun. Again, from the side, you can see that the tilt does not change as the Earth goes around the sun. So when a hemisphere is pointed towards the sun, two important things happen. First, days are long, and second, sunlight is direct. That combination of long days with direct sunlight creates the season of summer. The opposite is true when the hemisphere is pointed away from the sun. Days become short and sunlight is indirect. So we have few hours of less direct sunlight, and that creates the season of winter. Let's look at an example when the northern hemisphere is tilted towards the sun. When the northern hemisphere is tilted towards the sun, daytime is long. You can see how much longer the yellow arrow is compared to the gray arrow. That's a way of representing that the daytime would be much longer than the nighttime. In addition, the northern hemisphere would be receiving direct sunlight. So you would have a long day with direct, intense sunlight. that would produce warm temperatures, which creates summer. The opposite would be true in the southern hemisphere. In this scenario, daytime would be very short, nighttime would be long, and the sunlight would be indirect. So in this position of Earth, you would have short days with sunlight that does not provide much warmth. So short, cold days, which creates the season of winter. As the Earth revolves around the sun and the tilt now has the northern hemisphere tilted away from the sun, the opposite seasons are true. So when the northern hemisphere is tilted away from the sun, days become short, nights are long, and the sunlight becomes indirect. So short days with sunlight that does not provide much warmth creates winter. Obviously, in the southern hemisphere, it's the flip. Days are long, nights are short, and the sunlight is direct. So long days with intense sunlight. That creates the season of winter in the south. Now you might be asking yourself, what about the seasons of spring and fall? And for this, you'll want to have your notebook and we'll diagram the Earth as it goes around the sun. For this diagram, you're going to want to pause the video and copy the beginning of this diagram into your notebook. Once you have the diagram started in your notebook, come back, hit play, and pick up from there. Now that you have the diagram in your notebook, let's start with talking about December. Since we're in the middle of winter, why don't we start here? For this diagram, we're only going to be concerned with the northern hemisphere. So in December, we know that it is winter. We can also see that the axis is tilted away from the sun, and so that's going to create short days with indirect sunlight. Now thankfully, the Earth is going to revolve around the sun and come over to this position. So in June, thank goodness, we can start thinking about summertime. As the Earth revolves around the sun and gets to this position, you notice that the northern hemisphere is tilted towards the sun, and that will create long days with direct sunlight. So again, December is winter because the days are short and we have indirect sunlight. On the other side of our revolution, we're in summer. The days are long and there's direct sunlight. So what about the other seasons? Well, the other seasons of spring and fall are really just in between the two seasons. When we think about spring in the northern hemisphere, that happens in March. Spring is simply when Earth is in between the extreme of winter and summer. In March, the northern hemisphere nor the southern hemisphere are tilted towards the sun. Both hemispheres receive the same length of daylight and the same type of sunlight. So in the spring, when we're talking about the northern hemisphere, we're really just saying that days are getting longer and sunlight is becoming more direct. As we end winter, I want you to pay attention to the amount of daylight. You might notice that the sun is coming up earlier and setting later, and that temperatures are starting to rise. That's because the tilt, instead of being tilted away from the sun, we are now moving towards being tilted towards the sun. And of course, fall is the opposite of spring. Fall just happens as the tilt, instead of being tilted towards the sun, we're moving towards being tilted away from the sun. So the season of fall is really just because days are getting shorter and the sunlight is becoming less direct. Or you could say it's becoming indirect. So here are your key ideas. Earth's tilt creates the seasons, and the tilt affects the length of days and the angle of sunlight. When a hemisphere is tilted towards the sun, it is summer, and when a hemisphere is tilted away from the sun, it's winter.